Now, our next talk is on a case study using Computators. So we have Tim Rickards from SKM, and there's another New Zealander.
Thanks, Lee. I was a little bit nervous about doing this this morning, but I woke up this morning and thought, well, I can't look any sillier, so away we go. So I'll quickly go through a bit of an introduction, and then I've got a couple of case studies which I want to talk about. We've seen a lot of computators being used on road design. I just wanted to show a couple of things we've done which are in the urban design space, which aren't necessarily roads. So I'm going to quickly talk about Butler's landfill and a car park we've designed in Auckland. Quick thing about me, I'm an SKM civil engineer in Auckland. I've been using 12D for about 7 years, mostly self-taught in free time at SKM. I've been playing with computators for about the last 4 years and quickly become very addicted to them, and if you ask the other guys in my office, I probably use them a bit too much. They're very, very useful tools. So the way I've started using computators is making all of my models completely recalculable through a chain. I use a system where I've got master alignments which act as the skeleton for the model, and then there's a series of slave alignments which are computated off those master alignments and build up the rest of the model. So Butler's landfill. Butler's landfill is a site located on the west coast of the South Island. It's about 50 kilometres south of Greymouth. It was a virtual teaming project that our Christchurch office won, and when I got brought onto the project, they were still sort of developing what they actually wanted to do there, so the model was constantly moving. They didn't know how big they wanted. When we first started, they didn't even know what site they were working on, so it was an interesting project to start on, and the working in a virtual team also had its challenges for communication, and it meant that you're constantly changing your model. The other challenge in this model was the fact we had to model multiple layers on the landfill. So this is a pretty diagrammatic picture of a landfill. We had to model the base layer, and then also the drainage model, the drainage layer, the waste area, and also the capping layer. So all of these layers had to be completely 3D modelled, and then we were pulling earthworks quantities from between them. So if I flip into the model now. So I was quite fortunate in the fact that the Christchurch engineer didn't have much imagination and went with a nice square landfill, made it a bit more easy for me to model first up. So what we've basically got is a nice flat area in the middle with a bund around the outside, and once we fill up, so that's the base layer, and the drainage layer goes inside that, and then eventually once all the waste is in there, it's going to be a mounded landfill at the end. Now, I have quickly reproduced this model because I wanted to show the planning side of things rather than the finished product. It's actually going to be done in cells, so we won't build the whole landfill at once. It's something like a 10-year project or a 20-year project. If I go have a look at the alignments that control this landfill, there's only 3 of them. We've got this main one that controls the length, and then another one that controls the width, and then a third one that goes around the top of the batter. So these are the only 3 alignments I need to change any of the parameters in the landfill. There's then a series of slave alignments which sit on top of those and are fully computated off them. I can come in and change these alignments if I need to. So for instance, if I need to change a batter slope or change the actual full height of the landfill, things like that, you still have to come in and play with these slave alignments. But generally, you're just working with these 3. Off all these alignments, I'm then using MTF and apply many functions to produce a whole lot of design strings and tins for each layer of the landfill. And if we look at it in section, you can see the different surfaces that I'm creating. So there's the base layer, the top of the drainage layer, then all of this is waste, and then you've got the capping layer on the top. And I can create volume calcs between all of these layers. So if you go back into design strings, so one of the things we had to do in this was we were constantly changing the size of the landfill because the client and the designer couldn't make up their minds what they wanted, which is a little bit frustrating, but it helps me come up with a solution. So if I go into this alignment here, And let's say I want to reduce the size of the landfill by, or let's say I increase the size of the landfill by 10 metres. So that's extended this alignment just here. All I have to do is close the alignment editor and find my recalc menu, which seems to have disappeared. It's over on the other page somewhere. Okay, and then I just recalc the design. That's gone through and extended the landfill. All these strings have changed. We go back and look at this 3D model, that's grown by 10 metres. And I'm not just limited to going backwards and forwards, I can also change the width, change the height, pick up the whole landfill, move it down the site, change anything I want in there. The other thing that got created when I ran that chain was a series of volume reports between all the surfaces, which I'll talk about in a second. So if I go and have a look at one of these corners on this landfill, this is what the complicated thing and why I had to use all these slave alignments. And I know this has now been fixed in version 10, which I can't wait to get hold of. But when you do this, when you do a right angle corner, I'm sure you've all come across these loops that you get in your design strings. And there's a few ways you can go about fixing this. One of them is you can use a modifier to remove the string. That's change based at the moment, so it means that as soon as you change the length of your alignments, you lose that ability to, or you have to go back in and change the MTF file. So I said that wasn't an acceptable solution for us. And the other option was to put a radius on this corner so you don't get the loop. To me, that's having the modelling program drive your model, which isn't where you want to be. You want to be having your model being the key part. So the solution we came up with was to put another alignment string along the bottom there, which is computated off this main alignment string. So that's fully computated, and it means that we can then run a second MTF file on top of that alignment string to create all the surfaces. The other thing I did here was I used another alignment string to make a break line for our tin. If you triangulate this without the break line, you'll get these flat areas in the top here where the triangles are just creating off the nearest 3 points. So by putting a break line in, you can get your contours getting this nice sharp corner in here. And that break line's fully computated to those 2 points in both vertical and horizontal. So if you move anything, it'll go with it. So like I said earlier, we had to get this bulk earthworks completely balancing. And part of that chain file wrote out a series of bulk earthworks reports, which I've then read into an Excel spreadsheet. And you just have to re-import all those report files, and you can quickly see what your volumes are doing. So I can have a look at my my storage, my waste storage. We targeted 350,000 cube, so we're around about right there. And the other thing is we can look at the balance of earthworks. So this spreadsheet's telling me I have to lower my landfill. So if I go back into the model and lower my, where's my mouse gone? All I have to do to lower my landfill is go back into this MTF, alignment. And I can just change this, lower it by 0.5 metre, set, finish, and rerun all my design. It's recalculated all those volumes for me. If I go back to my Excel spreadsheet and reread in those volume reports, you can see that the balance has now come back to about where you want. Admittedly, I did know what to change it to there, so that was cheating. The other project I wanted to have a quick look at was an urban infrastructure job we're doing in Auckland at the moment, and it's a car park design. This is a lot more complicated than quite a simple square landfill, but we've basically modelled it using the same technique of a master string and then some slave strings off that. A couple of things in this design is we've got changing grades across the car park. We've got one curb string that goes right the way around in and out of all these little car park areas, and we've also got some swales in here which were a bit of a challenge to model. So these are the control strings that model this. That one there is the master one. That controls the height of all of that car park. It also controls the radius on these bends. Then you've got these four, which are all offset from that master, and the grade is offset between them, so you can make the grade go up and down at 3% or 2% or whatever grade you want. And it's all just a matter of going in and changing those computators to change that. Finally, we've got this one master string that runs up the middle, which is the access road to them. Then you've got a slave alignment, which is the curb line that runs around the outside. Now, admittedly, I had to use chainage in this, which is something I really hate doing, is using chainage in my computators. Really, again, looking forward to version 10 where I don't have to do that anymore. Because if you're using chainage and change anything, then you have to go back and reset all your changes to get it right. So if we go, the other thing interesting here was the slave alignments I used to do the swales. So if we have a look at this section, that top red line is the master alignment, and then I've done a slave alignment underneath it, which is just a vertical offset for the invert of the swale. But if I go and select on this, you see there's a second line that's come up here, which is what I'm using to control where these design strings start. If you don't have any vertical geometry on your alignment, you can't put any design strings on it, and I've sort of used that to my advantage by having a fixed line which is there in the vertical geometry but has actually been made invisible, so it gets removed. And it means I can set a grade from the back of my curb down to the start of my design strings, and it's fully computated, and it will start that swell wherever I want it to. So if I go back to the design, I can completely rerun this. It's got a tendency to break on me, which is, I don't see that as an issue. Even if you're rerunning a chain and all your alignments and they break on you, it's still quicker to go through and fix the computator that's broken than to redo this entire project from scratch like you would have to otherwise. So that's the major benefit of using computators in this sort of design. That's pretty much all I've got to show today. Thanks Lee for giving me the opportunity, and 12D guys, and looking forward to version 10. Cheers.
So thank you very much. It's great to see people using computators and just see what sort of power you can do with the ideas. And it's good for our programmers actually to see too how they are being used, just to so they keep doing more and more things for you.